Hi there guys, so today I'm working on my Colchester Master roundhead lathe. I'm in the midst of a restoration, as a few of you will know, and I'm working on getting a new motor installed today. So to do this I have raised the stock motor plate to its maximum tensioning capacity, and with this new motor mount it's actually still not going to be high enough to create the correct tension for the motor. As you can see, the motor is sitting crooked there, it's just hanging in place at the moment. But I've marked out on the plate roughly the edge of the base plate foot of the motor where it needs to be when the pulley belts are aligned and running level. So what I'm going to do is I'm going to remove this original mounting plate, and then I can actually drill it and tap it a lot easier than trying to do it in situ for the new motor position. As you can see, it has a selection of original motor mount holes, but none of these fit the newer motor mount style. So that's what I'm on with today, guys. Cheers. Alright there guys, so I've been getting this motor mount plate marked out for the new mounting holes that will be drilled and tapped to M8, but as it stands this mount wasn't coming up far enough to match the length of the original belts with the new center height of the new pulley. So I'm going to have to add a spacer. So I've got this piece of 25mm flat bar that's 100 by 100mm. So I'm going to break this down into 4 risers to go onto the plate underneath the motor feet. I thought about using just some M12, I believe they are, nuts as a spacer, as that would have been close, but I fear that using such a small diameter spacer will make the motor feet prone to cracking in the future. So rather than doing that, I'm going to go ahead and split this piece of flat stock up and make some proper sized spacers to bring this whole motor up slightly, well 25mm, to then give me a little bit to play with up and down on the original tensioning bolts. So I'm going to put the video back onto a time lapse here as I get this flat bar marked up, and then we'll go about getting it cut down to size. Hi there guys, so after a bit of fun on the bandsaw and the mill and the bench grinder, I've managed to make up these 4 25mm spacer blocks, and I didn't actually have any M8 bolts long enough, so I've just cut some M8 studs from some all thread and then Loctited those into the base plate, so when you change the motor you can just remove the entire thing and the spacers and studs stay in place. So I'm pretty happy with that. Nice chamfer on all the edges, nice thick heavy duty 25mm spacer that's going to support the entirety of the motor feet, so they're not going to be under any strain, but it also means that I don't have to use a solid plate, so I'm saving a bit of money on metalwork and weight, so pretty happy with that. And the motor just lowers on nicely, and it's got a little bit of play either way to get fine tuned for the belt alignment. Cheers guys, pretty happy with that. Hi there guys, welcome back to the shop. Today I'm going to be working on the original pulley from my Colchester Roundhead Master 1.5 lathe. This is the original pulley that I have bored out from its original imperial bore size to suit a modern 24mm shaft with an 8mm keyway. So I have bored it out, but I still need to cut the keyway. So I've been waiting for my broaches to arrive. I now have received the broach that I require, an 8mm broach. So this is what will cut the keyway into the pulley, but to use this tool I need to make a suitable bushing that it'll slide in, that will guide the cutter as it cuts through the pulley. And then you shim it out, cut again, shim it out, cut again, until you achieve the required depth. So that's what I'm tinkering on with today, and I'll be going through a couple of time lapses of what I'm doing. Hopefully you'll enjoy it. Cheers guys, see you later on. Let's get this keyway cut. Alright then, so first plan of action is to cut down some 30mm steel stock to a workable size that I can then mount into the lathe and turn down to the required size. So here we go. I'll just get this cut and then we'll come back once it's cut. There we go. Nice clean cut face. Happy with that. Now got a nice workable size piece ready to go into the Myford. Alright then guys, now we're over at the Myford using an ER40 collet chuck with a 29 to 30mm collet. Collet clipped in. Run up the slack. Now we can get the workpiece clamped in place nicely. So the depth of this bush that I'm going to be making is going to be about 50mm. So make sure I've left plenty sticking out there to work on. It's just rough for now. Hi there guys, so in the last couple of videos there you'll have seen me turning down the 30mm round stock into a 24mm brooch bush which has a 3/8 keyway suited for the 8mm brooch. So it's a nice snug fit. Obviously use a little bit of oil when I'm actually cutting it, but it's a nice fit. So this bushing now will drop into the internal bore of the original pulley from my Colchester master lathe, and on the first pass it settles on about the third cutting tooth, so I'm pretty happy with that. And then obviously you would just work through with your shims and slowly drive the cutter down once, then install a shim behind it and cut again, and so on until you've achieved the required depth for your keyway. So pretty happy with that. Nice fit on the keyway broach. Now I just need to get a press figured out to actually drive the cutter through the pulley without breaking it, so that should be fun. Cheers guys, hope you've enjoyed this little video. Hi there guys, today I've been working on getting the wiring loom figured out for my Colchester master roundhead lathe. This inverter will change the single phase power from the house sockets into 3-phase power that I can then use to run the motor for the lathe. I've made this in such a way that the inverter itself is easily removable if it needs to be changed, so it's mounted directly onto a rear plate which has some slots in the side, and then this decorative face trim will mount onto the machine, and I'm going to fit some riv nuts into the side here so that the rear plate can be removed with the inverter still in place, so in the future if I ever need to change it I can just remove the whole thing without any issue, you know. As well as that, I've ran the comms cables through one of these little 12-volt connection terminals so that they are also quick release, ready for if I ever need to remove it. Obviously this side is just communications, it's low voltage, so these small terminals should be absolutely fine. I've done the same on the mill and they've been perfect since, you know, I've had no bother with them. So yeah, happy with that so far. Cheers guys. Alright then guys, so I've been getting this inverter back plate just all filed down, getting the burrs all taken off, and I've got the riv nuts fitted into the back of this decorative box that I've made up for this inverter. So the back plate just has some slots there, and you will feed the inverter in diagonally, and then there's enough space inside the machine to actually spin the back plate and line it up with this decorative box. Obviously I haven't got it fixed in place yet, but should be what it will look like. So that's it slotted in place there, as you can see. So that's going to house the inverter, and I've just left it open with a bit of airspace around it, as the chip tray overhangs quite a lot, so I don't have any queries about it getting wet from cutting fluid or getting swarf build up on it, you know. I think I'd rather it just had airflow to keep it cool. And then, as I showed in the previous video, I've got the communication side of the inverter linked up to the original control levers for forwards and reverse, on and off. They will be connected using a quick release connection, so if I ever need to remove the inverter, I can just pop the connection off and change it out in the future if necessary. Slowly but surely getting there. Just need some new 240 mains cable, 3-core, to run a new line from the inverter to the socket for the machine, to provide power to the inverter single phase before it steps up to 3-phase. So getting very close now to being able to actually run the machine, but obviously I still need to put all the lead screw assembly back together. I'm still in the process of cleaning the saddle, and a few of the guards I still need to finish painting them as well, you know. I'm just working on this when I have time, when I can. So we're getting there, definitely making progress, and I'm happy with how it's looking. I like this inverter here. I just need to get the power supply for the coolant pump fed as well, and then I'm going to want a little switch possibly here or down beside the coolant door, so ideally with a little light, so when you flick it on it shows the coolant is on, and that should get me going for now. It's going to keep us busy anyway. Hope you're enjoying the videos, guys. Hi there guys, so I've been looking into what I can use that I've already got here in the workshop for powering the lathe safely, and you know, I needed some cable and I needed a breaker, so I think this is going to work perfectly. To be able to mount this unit to the back of the lathe, I need to be able to, I tried screwing from inside there, but then obviously I couldn't actually reattach the face. So to be able to mount this unit, I'm going to go ahead, and I've managed to do one, and I'm going to do the other now. I'm going to just use rib nuts into the plastic, which will then give me a secure fixing for an M6 bolt through the inside of the coolant area, out to the back of the machine and into the back of this unit, so it should hold it nicely against the back of the machine. And having this is going to give me a mains plug for the main inverter, the coolant pump and the DRO system, as well as it also has a USB port, so I can have a phone charger permanently in place on the machine for when I'm filming, or just for charging my phone, you know, can't hurt. Also, USB lights are readily available these days and pretty cheap, so that'll probably be what I use those two for. And then this unit is waterproof and has a 25 amp breaker on it, so that should be more than enough for the inverter that I'm running, and it just keeps it all nice and neat and contained and correct, so pretty happy with this. Hi there guys, today I've been working on getting the wiring loom figured out for my Colchester Master roundhead lathe. As you can see, I've now got the inverter installed in the enclosure box that I have made, and beside it I've fitted what was an e-stop switch, and that's to control the coolant pump. So as you can see, the main original safety lock lever controls the machine as it should to start it, and then when you flick the forwards and reverse selection lever, that also corresponds with the inverter, so the machine lever controls are exactly the same as they originally were. Really happy with how it's going so far. Just need to get some oil for the headstock. Getting really close. Hi there guys, so today I've been working on getting the electrics figured out for my Colchester roundhead master lathe. As you can see, I've got this enclosure cabinet built to house the inverter, and I've also fitted what was an e-stop switch, which will be my coolant pump switch. So as you can see, I still have the original 3-phase pump in there, but it's obsolete. So I'm going to be running this pond pump here, and if I push this switch, the pump switches on, and then you twist it and it switches off. So pretty happy with that. Just need to get a little sign or use the e-stop plastic plate and re-letter it with coolant pump rather than emergency stop, which I think could work pretty well. And powering that over on the other side of the lathe, I have fitted a distribution box which has a built-in breaker, 16 amp breaker, or 25 amp, sorry, and then 25 amp main breaker and a 16 amp breaker RCD unit with 3 sockets and a USB port at the bottom as well. So this is what's going to supply the power to the machine, and then that's going to be my coolant pump. Then these wires here will be connected up to a plug which will power the inverter, and that leaves me a spare plug for the DRO system as well. So that's a nice neat setup. I think it's going to be the easiest, safest way to do it, so I'm pretty happy with that. Let me know what you guys think.